Hello. You are about to witness one of the miraculous engineering achievements of the Victorian era once again. You may have heard of this structure. If you haven't, you should definitely watch this video. In 1865, engineer Joseph Bazalgette completed the Crossness Pumping Station in southeast London to pump sewage from low-lying areas into the River Thames. The building housed 4 beam engines, each weighing 250 tons, and designed to pump 6.5 million gallons per day, enough capacity for a population of 4 million, even though London at the time had only 2.5 million residents. The ornate cast-iron workmanship and decorative columns were structurally excessive. They were sized to withstand engine vibrations far beyond operational loads. The brick walls were 3 feet thick, though 18 inches would have sufficed. The engines operated until 1953, after which they were preserved. Today, 159 years later, modern electric pumps occupy the site, but Bazalgette's structure and beam engines stand exactly as they were built. Constructed like a cathedral, this sewage pump has outlived the Victorian London it served and remains standing as proof that engineering is built not only for immediate needs, but for impossible futures. Below this video, you will see a subscribe button. When you press it, you join those who understand what Bazalgette understood in 1865. Like the video and subscribe to the channel, because structures built for waste that seems as though it will never be produced often become the most necessary over time. The sewage crisis in 1850s London was urgent and deadly. The city's population had surged from 1 million in 1800 to 2.5 million by 1850. Medieval cesspits overflowed into the streets. Raw sewage flowed through open ditches into the Thames. The river had become an open sewer. In the summer of 1858, the Great Stink forced Parliament to close. The stench from the Thames made the building uninhabitable. Members of Parliament abandoned sessions. Something had to be done immediately. In 1856, the Metropolitan Board of Works appointed Joseph Bazalgette as chief engineer. His task was clear: build a sewer system for London. Not for the London of 1856, but for the London of 1900 and beyond. Bazalgette designed a network of intercepting sewers running parallel to the Thames, collecting sewage from lower-level drains and carrying it downstream to pumping stations. From there, the waste would be lifted and discharged into the river at high tide, where tidal currents would carry it out to sea. The system required 2 massive pumping stations, one at Abbey Mills on the north bank and one at Crossness on the south bank. The southern low-level sewer collected sewage from South London and brought it to Crossness, located in marshland beside the Thames in what is now the borough of Bexley. The site was chosen because it lay downstream of central London and low enough for gravity to carry sewage to the station, though pumping was required to lift it into the outfall channels that discharged into the river. The greatest challenge at Crossness was engineering scale. Bazalgette calculated that London's population would reach 4 million by 1900 and designed the pumping station to process 6.5 million gallons of sewage per engine per day. There was no hidden structural steel behind facades. The decorative ironwork itself bore the loads. Columns were oversized. Load calculations showed smaller sections would have sufficed, but Bazalgette specified massive castings with elaborate ornamentation. The logic was practical. When operating, the engines generated significant vibration. Undersized supports could develop fatigue cracks over decades. Oversized supports would absorb vibrations indefinitely without accumulating stress. The 4 beam engines were among the largest ever built. Each consisted of a massive 250-ton cast-iron beam pivoting on a central bearing. One end of the beam connected to a steam cylinder that provided pumping motion. The other end connected to pumps located in wells beneath the engine house floor. The beam rocked back and forth, hence the name beam engine, lifting sewage from the low-level sewer and forcing it into the high-level outfall with each stroke. The engines were built by James Watt & Company, founded by the inventor of the steam engine. Each engine had a name: Victoria, Prince Consort, Alexandra, and Albert Edward. The names were cast into decorative panels on the engine frames. The steam cylinders that powered the engines were 47 inches in diameter, with an 11-foot stroke. Steam pressure was supplied by coal-fired boilers in the adjacent boiler house. The engines operated at roughly 10 strokes per minute, slow, deliberate, powerful. Each stroke displaced thousands of gallons. Contemporary observers described the sound of all four engines running simultaneously as rhythmic and almost musical. The hiss of steam, the ringing of metal, the rush of water synchronized into a mechanical symphony that continued day and night, year after year, for 88 years. The decorative ironwork at Crossness represented an unprecedented level of craftsmanship for an industrial building. The engine house featured ornate columns with Corinthian capitals, decorative brackets supporting roof trusses, and intricate iron panels surrounding the engines. Every surface that could be ornamented was ornamented. The aesthetic was unmistakably cathedral-like: high ceilings, elaborate metalwork, a sense of grandeur seemingly inappropriate for a sewage pumping station. The motivation was partly civic pride. Bazalgette wanted Londoners to see that modern sanitation infrastructure deserved beautiful architecture, but the decorative elements also served engineering purposes. Thick cast-iron columns and brackets were structurally redundant, sized far beyond minimum requirements so the building could absorb engine vibrations without degradation. The brick walls were 3 feet thick at the base, tapering to 2 feet at the roofline. Standard industrial construction of the period used 9-inch single brick walls for machine buildings. Crossness used walls 3 times that thickness throughout. The justification was thermal and acoustic insulation. Thick walls would reduce engine noise and provide stable temperatures for machinery. But the true reason was permanence. Bazalgette built Crossness to operate for a century or more. Thin walls might crack under continuous vibration. Thick walls would endure indefinitely. Construction began in 1862 on marshland that required extensive foundation work. The site consisted of soft alluvial clay over gravel layers. Solid London clay lay 40 feet below ground level. Bazalgette specified that foundations be sunk to the clay layer using mass concrete footings. Each engine foundation consumed more than 1,000 cubic yards of concrete, far exceeding the engine's own weight. The foundations were designed not merely to carry static loads, but to absorb the dynamic loads of engines running continuously at full power. A lighter foundation might settle unevenly under decades of vibration, causing misalignment. Bazalgette's foundations did not move. The engines were installed in 1864 and tested throughout 1865. Crossness Pumping Station officially opened in April 1865, though full operation began later that year when the southern low-level sewer system was completed. The Prince of Wales attended the opening ceremony. Thousands toured the building, admiring the decorative ironwork and the scale of the machinery. The event was celebrated as a triumph of Victorian engineering and public health. London finally had a sewer system capable of processing the city's waste without poisoning the river or creating deadly epidemics. The capacity critics considered excessive proved necessary almost immediately. London's population continued to grow faster than Bazalgette had predicted. By 1900, the population was not 4 million, but 6.5 million. Sewage production exceeded early estimates. All 4 Crossness engines operated near full capacity in the early 20th century. Had Bazalgette built only 2 engines, as critics suggested, the station would have been overloaded by 1890 and required expensive expansion. By building 4 engines from the outset and sizing foundations and structure for maximum load, Crossness accommodated population growth without structural modification. The engines ran continuously for 88 years. Daily operations included stokers maintaining boiler fires, engineers monitoring performance, and maintenance crews performing repairs during brief shutdowns. The machinery required constant attention but operated with minimal modification. Cast iron beams designed with conservative stress margins showed no fatigue cracks despite millions of operating cycles. Bearings lubricated first with whale oil and later with mineral oils wore gradually but never failed catastrophically. Worn parts, bearings, piston rings, valve rods were replaced, but each engine's fundamental structure remained original. The decorative ironwork and thick walls proved equally durable. The ornate columns critics deemed unnecessary absorbed vibrations exactly as intended. Acoustic tests conducted in the 1930s measured sound levels in the engine house during full operation. Despite 4 massive engines running simultaneously, Noise levels were moderate. The 3-foot brick walls and cast-iron structure effectively dampened vibration. Workers inside could speak without shouting. Outside, neighbors heard only a low hum. The cathedral-like building functioned like a finely tuned instrument. Crossness operated until 1953, when new electric pumps were installed in adjacent buildings. The beam engines were decommissioned. For decades, the building stood abandoned. Engines silent, ironwork darkened. Demolition was proposed multiple times. Each time, preservation advocates intervened, arguing that Crossness represented irreplaceable Victorian engineering heritage. In 1987, the Crossness Engines Trust was formed to restore the building and engines. Restoration began in the 1990s with heritage grants and volunteer labor. Restoration revealed the extent of Bazalgette's overbuilding. The cast iron beams required only cleaning and repainting after 88 years of operation and 40 years of abandonment. Bearings were remachined and re-lubricated. Steam cylinders needed new piston seals, but no major repair. Ornate columns and decorative ironwork were structurally sound. Corrosion was superficial. The 3-foot brick walls showed no cracking or settlement. The 130-year-old foundations were as solid as the day they were poured. One of the 4 engines, Victoria, was returned to operation using compressed air instead of steam. It runs for visitors, demonstrating beam motion as it did in 1865. Modern sewage pumping uses electric motors and centrifugal pumps housed in compact, functional buildings designed for service lives of 30 to 50 years. These facilities are efficient, cost-effective, and replaceable. Crossness was none of these. It was expensive, oversized, and built without a defined service life. Yet it operated for 88 years and still stands 159 years later, while facilities built in the 1960s have already been demolished and replaced. Crossness's cost per year of service is lower than modern equivalents because it never required rebuilding, only maintenance. The sewage crisis that triggered Crossness's construction is often remembered through the Great Stink of 1858. But the deeper crisis was structural. Rapid industrialization created a city whose population outpaced its infrastructure. Sewers built for 1 million served 2.5 million. Disease was rampant. Cholera epidemics killed thousands. The Thames was biologically dead. No fish, no plant life, only sewage. Bazalgette's system, including Crossness, permanently solved the crisis. Intercepting sewers prevented sewage from entering the Thames upstream of Crossness. Pumping stations ensured waste was carried downstream and out to sea. Within years, the Thames began to recover. Fish returned. Cholera outbreaks ended. London became livable. The cathedral-like architecture of Crossness was intentional. Bazalgette understood that infrastructure serving fundamental human needs, sewage, water, transport, deserved dignity. The ornate ironwork and decorative columns were expensive and unnecessary for pure mechanical function. But they transformed a sewage pumping station into a civic monument, a building Londoners could visit with pride rather than shame. The belief that infrastructure should be both beautiful and functional characterized Victorian engineering, but faded in the 20th century. Modern pumping stations are hidden, functional, disposable. Crossness declared that even waste management deserved permanence and beauty. The 4 million population figure Bazalgette used in 1865 was criticized as wildly optimistic. London's population had never exceeded 3 million. Predicting 4 million seemed absurd. Designing infrastructure for such a figure was considered wasteful. Yet by 1900, London exceeded 4 million, and by 1930, it reached 8 million. Bazalgette's excess capacity proved barely sufficient. Had he designed only for the existing population, Crossness would have required complete reconstruction by 1890 at enormous cost. By designing for impossible futures, he created infrastructure that adapted as reality arrived. Today, Crossness Pumping Station stands in southeast London, surrounded by modern treatment facilities that have taken over its function. The beam engines are silent, except on demonstration days when Victoria operates for visitors. The building is preserved as a museum by the Crossness Engines Trust. But it is more than a museum. It proves that structures built far beyond apparent need often become the most practical over time. that engineering designed for non-existent populations can outlast engineering optimized for immediate requirements, and that the Victorian impulse to overbuild, criticized in its time and forgotten in ours, created infrastructure that served London for more than 150 years and will likely serve another 150. Bazalgette died in 1891, 26 years after Crossness opened. He never saw London's population reach 4 million. He never saw his sewer system serve 8 million Londoners. He built knowing the future could not be predicted, only accommodated. The sewage pump, built like a cathedral, with engines sized for waste London might never produce, ultimately served London as it produced exactly that waste and more. The critics who called it excessive are forgotten. Crossness remains,